So again, this is Calculus 1. So your section is BSCOE 1-3, no? And this is our second live session on functions and limits. We're going to continue a little of functions, and then after that, we will be proceeding to limits. So, today is October 22. Supposedly, our time is 6 to 9, but I agreed to you to meet 7 to 9. So, last time, we had the following, no? These things. And then we try to continue. So, this is now number 7. Given f of x is equal to 2x plus 1, g of x is equal to a piecewise function equal to negative 3 if x is less than 4. And it is equal to x minus x squared if x is greater than or equal to 4. So, we are asked of f plus g of x and then g over f of x. So, find the following. So, first, f plus g of x. So, again, how do we define f plus g? F plus g, when we apply it to x, we mean f of x plus g of x. So, f of x is given by 2x plus 1. But g of x is a piecewise function given by a negative 3 if x is less than 4. And it is equal to x minus x squared if x is greater than or equal to 4. Okay? So, we now combine piecewisely. So, 2x plus negative 3. So, because there is no restriction for 2x plus 1, so it means it can go with the less than 4, it can go with the greater than or equal to 4. So, when x is less than 4, so we have 2x plus 1 plus negative 3. So, we get 2x minus 2. So, that is if x is what? If x is less than 4. What about if x is greater than or equal to 4? So, we have 2x plus 1 plus x minus x squared. So, getting 2x plus x is 3x. And then, plus 1. And then, minus x squared. So, this is if x is greater than or equal to 4. So, again, 2x plus 1 plus x minus x squared is equal to 3x plus 1 minus x squared if x is greater than or equal to 4. Okay? So, I think this is already in simplest form. Nothing can be combined anymore. So, this is the sum. We call this f plus g of what? Of x. What about the other one? So, we have letter B. G over f, no? So, this is what we are asked of x. So, this is the answer for the first one. Now, what is g of x? G of x is g over f of x. G over f of x is defined as g of x over f of x. So, that is how quotient is defined, no? So, but what is g of x? G of x is equal to a piecewise. So, that is equal to negative 3 if what? If x is less than 4. And it is x minus x squared if x is greater than positive 4, no? Or equal to 4. Now, we are going to divide this by, so let's divide this by f of x. But what is f of x? That is 2x plus 1. So we now have, what's the result? So this is equal to piecewisely negative 3 over 2x plus 1. So is that right? Negative 3 and negative 3 over what? That is quotient, negative 3 over 2x plus 1. That is if x is less than 4. But the problem is, you will be encountering a value that is less than 4 that will make the denominator 0. Because we have 2x plus 1 in the denominator. So, negative 3 over 2x plus 1, it will become 0, the denominator, if x is what, guys? What do you think? If x is negative 1/2, right? If x is negative 1/2, which is less than 4, this is undefined. So we're going to exclude x equals negative 1/2. Although we want it to be less than 4, but we have to exclude negative 1/2 because it will make the expression, this negative 3 over 2x plus 1, undefined. So, what about when x is greater than or equal to 4? So we have x minus x squared all over, that is 2x plus 1. Okay? So this is if x is what? Greater than or equal to 4. So I think there is no problem with this anymore, no? Because 2x plus 1 is 0 when x is negative 1/2, which is not greater than 4 or equal to 4. So that's now the answer, okay? So we have, again, your x is what? Is not equal to negative 1/2 when x is less than 4. When you have your function g over f is negative 3 over 2x plus 1. So this is the quotient of g over f. When g over f is applied to x, so we get this piecewise function. Okay? Question, guys? Let's have number 8 if you don't have question. So let's say we're given this. Given, let's say f of x is equal to it is, let's say, 1 if x is less than negative 2 and it is equal to, let's say, x if x is greater than negative 2. So meaning we don't include negative 2. Well, while in g of x, so it is defined as it is negative x if x is what? If x is less than 1 and it is 2x squared if x is greater than or equal to 1. So we want to know the following. Now, could you please take a screenshot of this so that we will know what the given are when I move to the next slide. So when I ask you, you will be able to dictate to me. So let's say we want f minus g. I want f minus g here. What is f minus g of x? And also I want, let's say, g over f of let's have product this time. F times G. What is F G of X? And I hope one of you took a screenshot of this. So let's now move. So to make sure, I'm going to snip it so that I know what the given are. So let's now move to the next slide. So we have, and so this is the given. Okay? First, we want to know F minus G. So, solution. What is F minus G? Of X. Now, for F minus G of X, so that is equal to, again, F of X minus G of X. So that is how the difference F minus G is defined. So it is equal to, when you apply to F of X minus G of X. But what is F of X? F of X is 1 if X is less than negative 2, and X if X is greater than negative 2. So I am supposed to add it to G of X, no? So we have, to be able to combine F and G, so we need this number line so that we know where they will meet, no? What is common to those two functions. So the cut-off points are the following: negative 2 and 1. Negative 2 and then 1. So it means there are now two intervals, sub-intervals. Here, there are two sub-intervals. Here, there are also two sub-intervals. If you combine them, so we'll now have 1, 2, 3. There will be 3 sub-intervals. So F minus G will now be split into 3 equations or formulas, no? Corresponding to the 3 sub-intervals. So we now have F minus G of X is equal to. So in the first interval, we have negative 2 to the left of that. So we have, when X is to the left of negative 2, so what is F of X? So 1. So that is equal to 1. So we have 3, no? So if X is less than negative 2, so this is the number line X. So F of X is defined as 1 minus G of X. But G of X is defined as what? Negative X if what? If X is to the left of negative 2, because less than 1, that is covered, no? Less than negative 2 is covered in less than 1. So I'm going to use negative X. So minus negative X, so it is now plus X. So that is if X is what? If X is less than negative 2. What about if X is between negative 2 and 1? Between negative 2 and 1, so what is the sample number between negative 2 and 1? Let's say negative 1, no? 0. Or where is negative 1? Where is 0? Less than negative 2 or greater than negative 2? So it is greater than negative 2, right? So if you are to the right of negative 2, so we use x, which is x greater than negative 2. So we now have x. So that is my f minus g. What is g? If x is between negative 2 and 1, where is that? Is it less than 1 or greater than or equal to 1? So it is still less than 1, no? So I'm going to use negative x minus negative x, so plus x. That is if x is between negative 2 and negative 1. I mean 1. Okay? Now, what about if x is to the right of 1? To the right of 1, so it is greater than negative 2. So I'm going to use x again for f minus g. But what is g? When x is to the right of 1, so it is 2x squared. So minus 2x squared. That is if what? If x is greater than or equal to 1. But for the meantime, let's pause for the equality, no? We need to know where the value really covered, whether is it at the middle or at the last or at the first. Let's see. If x is equal to 1, what's the value of 2x squared? So that is equal to what? It is equal to, if x is equal to 1, if x is equal to 1, because it is included, no? So this means that g of 1 is equal to, what's the value? 2, no? 2 times 1. So what about if x is less than is equal to 1? What's the value of f of 1? F of 1, when x is equal to 1, where is that? So it is greater than negative 2. So I plug in here. I plug it here in x. So it is equal to 1 or no? So if x is equal to 1, f of 1 is, which is greater than negative 2, yung 1. So x is 1. So what is the difference? F of 1 minus g of 1. So that is equal to 1 minus 2. So that is equal to f minus g of negative of 1 is equal to what? 1 minus 2. That is negative 1. No? So where is negative 1 here? Let's check which one will give negative 1. Plus 1 plus 1, that is, negative 1 plus negative 1, negative 2. So definitely not here. What about here? 1 minus 2 times negative 1. Negative 1 minus, what is the value of x? 1, no? 1, at dito pala, 1 plus 1, that is 2. So, it's not negative 1. So, here, 1 minus 2, dito, here, do you see the arrow I'm pointing? That is negative 1. So, it means it is really included here. Okay? So, we are now sure that it is included in that. Now, in case, let's say, that it so happens only, it so happens that the same value you get in the middle and in the last. So you can include the one either here or here. It doesn't matter. It means they are connected. Okay? If they will have the same value. So since they do not have the same value, it means they are not connected. One is above the other. No? And then one is a point, then the other one is a hole. But they are aligned vertically. Hole and a point. Okay now? So we can now conclude when simplified. So let's now simplify. We can now conclude that f minus g of x is equal to, what is that equal to? When simplified, guys. So 1 plus x, still 1 plus x. So we cannot do something about it. If what? If x is less than negative 2. What about if x is between negative 2 and 1? So that is x plus x, which is 2x. So that is if x is what? If x is between negative 2 and 1. And then it is equal to x minus 2x squared if what? If x is greater than or equal to 1. Okay? So that's now the value of f minus g of x in terms of piecewise function. That is how we define f minus g. What about the product, no? So this is now the answer. What about f plus g? I mean f times g. F times g. Are you still alive, guys? Guys?
Yes, sir.
Fg of x. What about fg of x? So fg of x, so we multiply, no? So let me move this given. I'm going to move this given. I can't move it. So can't move. I'm supposed to. Why is it that I can't move it? Yeah. See. It's already grouped. So that's why I can't anymore snip it. I mean lasso. Lasso in this case. Let me shrink it because I need much space. I'm going to wear my eyeglasses. It's hard to look at the screen. Once you get old, it's now difficult to look at the screen. At least you were young. Now the reason why I choose green so that it will not strain your eyes. Imagine if this is very bright color, your eyes will be suffocated or will get strained. So we have Fg, F times G. So how do we multiply them? So again, there are 3 intervals. So let's consider the first interval to the left of negative 2. What is to the left of negative 2? So f is 1 times negative x. Because to the left of negative 2 is less than 1. So it is covered in less than 1. So negative 1 times negative x is negative x. Then, what about if x is between? So this is less than negative 2. It is between negative 2 and 1. So between negative 2 and 1, sample is 0, no? So where is 0? Greater than negative 2, right? So that is greater than negative 2. So we have x times, I'm going to multiply that where? To g. But what is g? Between negative 2 and 1, example is 0. So 0 is less than 1. So I use negative x. So times negative x. So that is if x is what? If x is between negative 2 and 1. And what about to the right of 1? To the right of 1, so that is greater than negative 2. So I will use x for f times g. So I will use 2x squared, no? So times 2x squared, 2x squared. So that is if x is to the right of 1. I think it's equal here, no? The 1. So let's check to make it sure if it is really here. If x is 1, so it is x, no? F of 1 is equal to 1. So 1. So remember I have 1 times. So it's equal here. So 2 times 1 is 2. So it's really here, no? Same. So 2 times 1 is 2. So we are now sure that it's really in this interval. So this is the formula. So let's simplify. So negative x the middle, negative x squared. So that is if x is between negative 2 and 1. And it is equal to negative x. That's already simplified. If what? I think this is getting higher. Let me move it a little down. So if x is between negative 2 and 1. And it is x negative if what? If x is less than negative 2. And then finally, it is 2x cubed. It is if what? If x is greater than or equal to 1. So if you are asked of the domain, the set of all real numbers except negative 2, no? We don't include negative. Okay now guys? So that's it. So that is f, g, of x, no? Yung problem lang kapag in case merong quotient, you have to be careful with that. You have to remove the value that will make the denominator 0. Be careful with that. Okay? Now, there is an important function very useful in calculus. I do not know if you had this. This is called a piece, not that one. This is called greatest integer function. Greatest integer function. So what is a greatest integer function, guys? Anyone who has encountered this? If you are computer engineering, we call this in computer int. Greatest integer function. So in computer, it is int. It is useful in rounding down numbers. Let's say you want to round down a number, so you can make use of this. 2.9, you want it to become 2. 2.9999, you want it to become 2. You use greatest integer function. So in computer, this is called int. Int of x, int. You type in Excel, for instance, equals int, open, close in parentheses, negative 3.7, you will get negative 4 because rounding down. Negative 3.7, rounding down, meaning going to the left. Pull it to the left, negative 4. Okay? 3.9, 3. So the value. This is how it is defined. The notation, by the way, this is the notation. Maraming notation, no? There are a lot. So ito yung gamitin sa calculus. Pero, as I said, maraming ginagamit na notation. Yan. So we call this greatest integer function. And it is defined as what? Smallest integer, greatest integer. Wait a minute, it's going to turn off na. No more charge. Buti I was able to sense it. Otherwise, I will be out of the Google. I will be kicked out. O see? Almost. So, greatest integer less than or equal to x. Greatest integer less than or equal to x. Pinakamalaking integer pero equal or less sa x. Ano yung pinakamalaking integer na less than or equal to 4? Corpus. Darren. What is that integer? The greatest that is less than or equal to 4. Not speaking. Cedric, Mark. No answer. Hey guys, are you still there?
Yes po.
Oh.
Yes po.
Oh. What about corpus? Who wants to answer? What is that greatest integer less than or equal to 4? Huh?
4.
So 4. Because equal. So the greatest integer of 4 is still 4. So if your given is already an integer, that's already the answer. The greatest integer of negative 3 is negative 3. So, but if you have a decimal, let's say I have a decimal, greatest integer of 2.8. What is the answer? Even it is 2.897. What's the answer? Greater than, greatest integer less than or equal to 2.897. Pinakamalaking integer, pero dapat less than or equal sa 2.897. Possible ba yung 3? Hindi naman yung less than sa given. Dapat less than or equal. So, ang possible is 2. No? So, what if I have negative pi? Negative pi. What is the greatest integer of negative pi? Negative what? Negative what? Ay, CPE people.
5. Negative 5.
Negative what?
5.
5? Like this? Negative? Negative 4. Because to the left. Because negative pi is somewhere here. And negative 4 is somewhere here. Negative 3 is somewhere here. Negative pi is in between negative 4 and negative 3. Remember, we are pulling it to the left. Kung vertical ka, pulling down to the next integer. Kung hindi siya integer. So, it is not integer, negative. It is actually negative 3 point something. Negative 3 point something, round down, negative 4 to the nearest integer. No? Negative 4 children. Okay? Is that clear, guys? Okay now, ha? Now, by the way, other notations.
Yes, sir.
So, these are other notations. Other notation. The reason why I left space here. Other notations. Maraming mga notation yun. Iba-ibang book, depende sa book. Ang greatest integer ay ganito, yan. May book ganito. Yan. Patapos yan. Included ang x, pero less than, na papuntang kaliwa, ibig sabihin. Okay? Papuntang kaliwa. Cannot be to the right. So, hinihila niya pababa. Maaring mag-equal sa x or less than. Yan. Maaring siyang tama ba? O baliktad ako? Less than, baliktad. It should be, kasi dapat x, hanggang maximum niya hanggang x, hanggang right, hanggang magiging bracket siya, pero less than that. Halimbawa, 4, equal yun. Pag 3.9 to the left, magiging what? 3, no? Next, we have, pwede rin yung iba naman, ganito. Yan, dito. Wait a minute. Parang, I'm not really sure. I'm doubt of the first notation. Kasi, sumasama siya sa x. Ay, no, tama. Baliktad. Tama nga. Ang bracket dapat nasa left. Kasi ito nasa down eh. Nasa ilalim eh. So, it should be here. Yung mga other notation. Pero ito yung commonly used. O kaya ito. Yan. So, we now have but in case mali pa rin to, you just correct me next meeting. Pero ang alam ko, dito ang bracket. Yan. Like this. Yan. There are some notations. In computer, int of x. Ang opposite nito, ceil function. But then hindi na natin di-define ang ceil function. Kasi you can define ceil function out of greatest integer. Okay? Ang gagawin mo, greatest integer plus 1. Ceil function yon. Ang ceil function opposite, pulling up, round up this time. Great, yun ay ceiling. But you can define ceiling out of greatest integer. Okay? How does the graph look like? And what is the domain range? The domain of the greatest integer function, children of the Philippines. So what's the domain, guys? What's the domain? guys, any real number. So meaning negative infinity to positive infinity. I didn't know I didn't know joining or leaving. If the sound is that, is somebody is leaving or want to join. Let me see, let's check. No? Baka there some people is joining. No one is joining. Okay, I think none. Okay, so we now have range. What about the range, guys? Huh? What is the range? The range is set of integers. Always an integer. So this is set of integers. Okay? Now, how does the graph look like? So, the graph looks like this. So, let's draw a graph. We'll draw the graph for some only. So, for a certain part only of that domain. Can remove to join this. I don't know what does this. Admit. I have to admit. Siguro next time I do not know how to host another person. So he'll be the one to admit the classroom. Okay? So let's have this. So this is the x-axis. This is the y-axis. Let's use other color for the diamond for scaling. 1. So 1 here. 1, 2, 2, 3, 4, 5. Let's have up to this. But it doesn't mean up to this only. Huh? It goes beyond. No? 1, 2, 3, 4, 5. Okay? So here, 1, 2, 3, 4. Negative 1. So actually these are negatives. 2, 3, 4. Okay? So this is negative 4. Yeah. Do we need white one? Okay. So negative 4. This is negative 2. Positive 2. This is positive 4. This is 2. 4. This is negative 4. Negative 2. Okay. So let's now this time use this pink. So when x is between negative 1 and 1, remember our function is what? Our function is greatest integer, no? If x is 0, what's the value? 0. No? If x is 0, 0. If x is 1, what's the value of the greatest integer? Guys, it is 1. So it's here. If x is 2, it is 2. If x is 3, it is 3. If x is 4, it is 4. And then if x is negative 1, negative 1. the value of the greatest integer. Negative 2, negative 2. Negative 3, negative 3. Ay, what happens? So, negative 3, negative 3. Naduduling na ako. Ang hirap tumingin sa screen. Negative 4, negative 4. So, after 3 months pa, perhaps, baka ano na ako, yung ano yung maitim, yung babaeng maitim sa artista, yung duling. Yan. Okay. Dapat na nagpo-form ng straight line. So, we now have this pin. Pero pagdating ng negative ng 1, open. It is open. Yan. It is open. Again, pagdating ng negative 1, it is open. Then, here, pagdating ng 2, it is again open. Yan. Pagdating ng 2, open. Ito, open ha, open. Pagdating ng 3, ay ng 2 dito na. Pero pagdating ng 2, open sa dulo nito. Ay pagdating ng 3. Bakit? Kasi, Kasi when x is 3, negative, 3. Pagdating ng 3, dito yan. Pero pagdating ng 4, open uli. And so on. Yan. Did you get that? Yan. Okay? Yan. Open. So, you know that the trend open here. Is it recognized as open? So here, but open here. Open. So again, open here. Open here. So that's how the graph looks like. Okay? So yan. Okay, so this is the graph of the greatest integer function, and so on, and so on. Now, if you look at the range, so the value of y are all integers, no? The values of y. And for the x, any real number. Okay? So, next number. Let's say you are asked of this example. Oh guys, determine the graph, sketch the graph. Sorry, wrong instruction. Sketch the graph of f of x defined by, so this is how it is defined. It is equal to greatest integer of x minus x. Okay? So, sketch the graph of f of x equals this. Also determine the domain and range. Determine the domain and range. And range. Yan. Okay guys? So, we now have the graph, no? For the graph, so solution. So first we define this piecewisely. So how do we define f of x piecewisely? So let's have um, note here. I left because I supposed to have it uh, restricted the graph. Note, graph sketch on the domain sketch on the interval, sketch f on the interval negative, let's say 4 to 4 only. I want the graph from negative 4 to 4 only. Okay? So, the graph, because I cannot graph the whole like this. So we now have f of x. So let's define f of x. So how many? So let me first define it. 1, 2, 3, 4. Mga 4, no? So this is the middle. Let's say this is the middle, number. How do I get rid of this, no? Yan. If x is between, so there is an interval. If x, let's say, if x is between negative 0, start with 0. If x is between 0 and 1, no? Including 0. Because as you notice in the graph, so the left endpoint of every segment is included, but the right endpoint not. So how do we define this piecewise? I mean this greatest integer. If x is 0, so this is 0. So it is 0. Okay? Then minus. If x is let's say more than 0 but less than 1 is still 0. So between 0, including 0 to less than 1, this is always 0, the greatest integer, minus x. So minus x. So meaning it is negative x. No? Yeah. What about if x is between 1 and 2? If x is 1 or less than 2, it is always 1. So this is 1, always 1. But this can vary. So it's still x. Again, if x is between 1 and less than 2, from negative 1 to less than 2, the value of this greatest integer is always 1. So this is always 1 in this interval, minus x. Let's have the, I think we have another one. Kailangan natin hanggang what? Hanggang 4, no? Less than, I should have written it down. Let me copy this. Para tayo, decreasing. Ito sa ilalim ko lalagay. Para pababa. No? Tama ba? Ito tumataas to, no? Ito tumataas, sorry. It's alright. Tama pala. Kala ko pumababa. Dapat pababa eh. Dapat mula sa negative. O nga, tama. This should be where? Sa baba. Kasi I want it increasing. Ito dapat ang sa baba. Yan. Okay? So, this is erased. Yan. So, we now have, if x is between 2 and less than 3, this greatest integer is always 2. So, that is fixed. Then, minus x. Now, if x is, and we are now close, 3 to less than what? To less than 4, including this, so we have what? 3 minus x. And then the last one, let me because it's too, what we call this? It's too many. I'm going to decrease this one. Papagod ako. Total, all you need to know is at least how it looks like, no? Hanggang 3 na lang. Yan, hanggang 3. Nakakapagod magawa. 3. Then, to negative 3. To negative 3. Buti kung kayo ang nag-graph. Hanggang 3 na. Negative 3 to 3. Okay na yan. Pero hindi ko na kailangan hanggang 4. So, this is still the equation. Okay? So, I am expecting of 1, 2, 3, 4. So, I need to move this down. Yan. Move it down. Okay, enough? Do we have enough space above? I think so. Ayan. Naglalag. Ay, that's the problem of computer or internet. Naglalag. Let's move. Yan. Okay? So, if x is, yan, let's continue. Yung iba, tulog na 18. If x is between negative 1, between, ano nang below 0? Negative 1, ano? Negative 1 and 0, including negative 1. And then we have if x is, you know already the trend, no? If x is between negative 2 and negative 3, including negative 2. If x is between negative 3 and what? Negative 4, including what? 4. Okay? So, meaning if 4, you have another hanggang dito sa 4. So, if x is between negative 4, so included there, hanggang 5, but the graph is up to negative. Ang sabi ko pala, negative 3 lang, ano? Kaya pala, ang taas na masyado. Naging excited. You're so excited, Mr. Marquez. That's enough, because we have no negative. Okay. So let's now get the equation, the formula for that. So this is negative 1. You see the trend? Negative 1 minus x. So here, negative 2 minus, what is here? Negative 2 minus x. What about here? Negative 3 minus x. These are all segments, no? So actually, not really segments, pero half. Endpoint, may endpoint at mayroong open hole sa dulo. But these are inclined. Na unlike this, these are horizontal. So this is now my, and so on yan, and so on supposedly. That is how we define the actual f of x. This is the actual f of x. Yan. Nako. Kailangan ko ng a very nice, anong tawag dito? Yan. Brace yung ginagamit sa ngipin. Ang application nito sa ngipin, yung brace. Yan. Tawa naman. Ayaw tinagtumawa. Sorry, corny. Okay, so let's now draw each piece. Let's now draw. So we now have, let me put the ruler again. This is my ruler. My beautiful ruler. Yan. And then, I'm going to have, let me rotate it 90 degrees. Faster. I do not know if there is a shortcut of putting to 90. Yeah, let's now have this. Okay. This is a now ruler. So you have now here. I think it's too long. Okay. Bye, ruler. See you later. y. The maximum value of f is what? If x is, let's say, negative 3 minus 3, it is what? Sorry. Negative 3 minus negative 3 minus negative 3, 0. When x is 4, negative 3 minus, mga negative to, negative. Parang baliktad ako. Baliktad ako dito, no? Dapat dito, 0, negative 1. This is negative 2. Because the interval is wrong. Because negative 1 to negative 2. Negative 2 to negative 3. Negative 3 to... ba't mali pa rin? Paano ba? 0 to... This is negative 1 to 0. 4, 3, 2, 1, 0, negative 1, negative 2. Yun. How about 3, 2, 1, 0, negative 1, negative 2, negative 3, 4, 3, 2, 1, 0, negative 1, negative 2. Okay. So, yan. Mali yung interval ko. Siyempre, dapat mas malaki yung negative 3 kaysa negative 2. No? Ay, mas maliit. Dapat ang nasa right side, mas malaki. Okay. So, when x is negative 3, for instance, negative 3 minus negative 3, 0. When x is negative 2, negative 3 plus 2, negative 1. So, ibig sabihin, 0 here, then negative. Ibababa ko, I want to delete this. Nadi-delete kaya ito? Delete. Dahil nasa negative. Again, let me have the ruler. By the way, you are already in college, ha? Don't expect that what we are going to study are senior high school topics. So, we are not going to study senior high school topics, college, and pang-UP kasi tayo ay UP, but with additional information, polytechnic. So, when x is, let's start with the middle. When x is 0, 0 minus 0, it's 0, children of the Philippines. So, it's 0. When x is 1, 0 minus 1, that is negative 1, but not included. Negative 1. When x is 1, negative 1. Let's say ito yung 1. Laki-laki ako. Ito yung 1. Ito ay 2. 2. So this is x. This is negative, positive 1. Is it smaller or enough? And then negative 1, negative 2. Negative 2, negative 1, positive 2. Okay, this is 1, no? This is negative 1. When x is 0, 0. When x is 1, 0 minus 1, negative 1, but not included. So let's say this is negative 1. Negative 1. But not included, children. Let's have the graph. Not included. So here, not included. Open. Kasi not included. What about if x is, let's draw that. Be ready with the ruler. That is inclined 45 degrees, I think. 45 degrees. Yan, here it goes. Yan, medyo mali ka. Hindi kasi para sa scaling ko. Okay, yan. So that's the graph. Let's use the blue one. Yan. So let me make it thicker. Okay. Yeah. Next. What about if x is between 1 and 2? When x is 1, 1 minus 1, 0 again. When x is 1, y is 0. Or f of x is 0. When x is 2, 1 minus 2, negative 1 again. When x is 2, negative 1. But open. So draw a line, or withdraw a line later. Okay? Kaya lang hanggang negative 3 ang dapat na drawing ko, no? Okay lang. Negative 3 to 3. Kayo na magtuloy, ha? Lalagay ko na lang dot, dot, dot. Kayo na yung yan. Basta ganyan yung pattern. O kaya tanggalin na lang natin itong note. Tanggalin ko na yung note. Alisin na natin yung do, re, mi, fa, sol, la, ti, do, note. Na, yung ating mga plano nawawala. Kasi ang hirap pag hindi mo matansya ang space, eh. Because this is not the actual black hole. So when x is, punta naman tayo sa taas. When x is negative 1 minus negative 1, 0. So when x is negative, ala, nabura. Yan. What is that? Ayan lang ang maganda sa PowerPoint. You can undo. When x is 0, negative 1 minus 0, negative 1. So open here, open. Okay? It's open, they're open. So we now have this. When x is negative 2 minus negative 2, negative 2 minus negative 2, 0. So 0 here. When x is negative 1, negative 2 minus negative 1, negative 1. So again, open here. Nasa na ba ako? When x is negative 1, but open, no? You know, when x is negative 1, so open. So open here. Okay. So I will now draw. Yan. Mga parallel line yan. Mga parallel line, children. Yan. O, ganyan how it looks like. Children of the Philippines. Oh, see? Is it amazing graph? No. No. Yan. So like this. Oh, see? Okay. So that is how the graph looks like. And it continues, no? Ito here, when x is 2, when x is 2, ang graph niyan is actually 2. When x is 2, ayan, no? It is 0. When x is 2, it is 0. You know, 2 minus 2, 0. And when x is 3, it is actually negative 1. Yun yung susunod. Ayan. I-draw lang natin yung part na to. Pero of course, hindi na siya makukomplete. Ito yan. Yan. That, of course, that na. Yan. Tuloy-tuloy na yan doon. Okay. Kasi wala na tayong enough space there. So that's the graph. O, di very easy, guys? Yan. Kaya expect, ha? Tingnan nyo ang inyong magiging exercises. Exciting. Pag kayo nagsimula na. Siguro, matataranta kayo sa pag-google. Hindi magsasagot, kundi mag-google. Naku, ay yan ang alam ko na yung pag mga online. Naku, maniwala ko, you are going to answer. Really. You're going to Google it. Hahanapin nyo, but don't worry. You will not find it in the Google. No? You cannot find it in the Google. But it is hidden in the Firefox. I hid it in the Firefox, okay, or Explorer, so that you can find it. Okay, guys, are you still alive, guys? Guys. Oh, what about the domain? Oh, what about if I ask of the domain, guys? What's the domain, guys? Oh, ano nakikita niyong domain? Pwede bang i-input ang any number? Yes. Di ba? Any number can have values. O may mga integer in between. So, set of all real numbers. What about the range, guys? Hanggang saan naroon lang ang graph? The graph is limited from what? Between -1 and 0, including 0. From -1 up to 0. Yan, that's the range. Look at the graph. It doesn't exceed 0. It doesn't exceed -1. And it cannot be -1 in the range. They are open, right? Open in the -1. But at 0, when y is 0, okay. So that's the graph. Okay now, guys? Yan. Meron pa tinatag na sine function or signum. Yan. Ano naman yung signum function? Guys, ito na yung signum function. Kayo na lang mag-graph. Madali lang i-graph siya. I will just define it to you. Signum or sine function. Signum or sine function. Let me use other color to emphasize. Signum or sine function. Obvious from the name. Signum or sine function. Latin, signum. English, sine function. What does it mean? If your f of x is a sine function, kaya what will be the function, guys? Do you have any idea? What is f of x? Ano ba yung mga sign ng mga number? It's either -1, neutral, or 1. Yan. There are only 3 possibilities. It's either -1, 0, or 1. This is if x is what? If x is less than 0. If x is 0, exactly 0. If x is greater than 0. You will be encountering this function, yung mga function na yan, when you go to application ng mga computer. Sa computer, yan yung gusto mo maging negative ang isang, yan ang multiplier nyo. Sine function. Ang sa computer, SGN I think. SGN. In computer, SGN. Kaya tingnan nyo, what is the SGN of -4? The answer is -1. In computer, so sa mga software, like Excel, you type in Excel. So we have, sine function is SGN. Okay, signum function. So again, this is SGN of x. SGN of x. I-type nyo sa in computer SGN of -3. Ang lalabas, what, children? -1. Pag tinype nyo SGN of, let's say, 4.8, what's the answer, children? 1. What about if SGN of 0.00001? 1 pa rin. Very good. Pag mga CPE, magagaling. Wala lang yung mic perhaps, kaya hindi makasagot agad eh. -pi ay -1. No? Ay, gawin naman natin 0. Wala pang 0. 0 ang lalabas. Okay? Marami pang function na kayo mamimit. Actually, hiniram yan sa calculus o saan man. Okay? Let's now proceed to calculus. Magka-calculus na muna tayo, guys. We begin with, so let's start now talking about calculus. We are done with reviewing functions, which are very useful in the study of calculus. Because the ingredients that you're going to use in calculus, functions. So these are the flavors. But the main recipe, of course, is about limits. And in fact, limits are divided into what we call derivative and integral. They are both limits, children. So, what is calculus? This is what I got. No? calculus is the mathematical study of continuous change and motion. So, meaning when you talk of change, you talk of moving object, you talk of decrease, increase, inflation rate, and so on. So, that is calculus. Whenever there is a change, there is a motion. So, that's what calculus, where calculus gets in. And when you say change, motion, so that has something to do, motion or change has something to do with limit. So, calculus also can be defined as the study of limits. In particular, limit of a function and limit of an area. Limit of a function in differential calculus, limit of an area in integral calculus. There are two people behind this calculus, Sir Isaac Newton and Gottfried Wilhelm Leibniz or Leibniz. Yung iba Leibniz, yung iba Leibniz. Pag American Leibniz, but what I know pag German Leibniz or Leibniz. Yung iba pa Leibniz. Now, of course, we're not the only people really behind calculus, but these were the people who began calculus. Without them, so they couldn't have started calculus. So who are they? Sir Isaac Newton, he was an English. Gottfried Wilhelm Leibniz, he was a German. So before they invented calculus, these two places, England and German, they came into conflict. So according to the people of England, they were boasting something that they invented, represented by Newton. So according to the English people, we invented something and we will not be sharing it with you. So kasi galit nga sila to what? To what we call this? To German people or to Germany. But according to German people, so we discovered something. We will not tell this to you also. But they, without knowing, these two people or these two countries, they have invented same thing, and these are calculus independently. So imagine that, different symbolisms, but they came up with what? With the same concept, same idea, and that is calculus. Okay? So, there are two branches of calculus generally. One is differential calculus, then the other one is what? Integral calculus. For differential calculus, it deals with the study of instantaneous rates of change of functions, especially very small change. So calculus can handle that. And slopes of curves. So that is what differential calculus is all about. So when you talk of rates of change, how fast is a certain quantity is changing. And when you talk of how fast a certain quantity is changing, that is also related to what we call slopes of curves. Remember, slope, that is how fast is the x value changing relative to what? To the y value. So that is what slope means. So when you say differential calculus, talking about instantaneous rate of change of functions and slopes of curves. It concerns the study of and evaluation of and use of derivative and differentials. So what do we study in particular? Evaluation and use of derivatives and differentials. So meaning these are the quantities that we are going to compute, derivatives and differentials. Do you know that derivatives are simply slopes, special slopes? It's like logarithm. It is an exponent, a special exponent. No? So that's what derivative is. And differentials, so related to derivatives, but they are different. You will learn that once we are already in differentials. Small change. So differentials are changes, no? So example that we study in calculus applications, instantaneous velocity. When you talk of velocity, you talk of acceleration, you talk of population, that's derivative. Okay, the neutral name is derivative. So rate of change of population, rate of change of current with respect to time, velocity, acceleration. So when you do physics, you will do a little, perhaps your teacher will derive velocity, and that is in terms of limit, and that limit is the derivative. Okay? So I do not know if you had that physics already. Are you already enrolled in physics, children? Guys?
Di pa po, sir.
Not yet. Okay. So that's what derivative means, no? A differential calculus. So the important tool or quantity that we study in differential calculus, derivative of a function. This is what we are going to compute, derivative. So this is what we are going to measure in differential calculus, derivative. And there are so many applications, of course. And we apply derivative to a function. So we get derivative from a function. That's why we review function. Okay? So let's say you have a function y equals f of x with the condition that there is no hole, there is no break from what? From a certain interval. So let's say there is a center interval, there is no break, no hole. Okay? So the function is continuous on that. So that's what we require for the function to have a derivative. Continuity. So we now have this picture to represent derivative. Yan. So it is actually the slope of the tangent line once it becomes like this. So the third picture, this is a tangent line to P, at P on the curve. The slope of that tangent line to P on that curve is the slope of the curve, which is the derivative. So you imagine a point moving, traveling on the curve, and then approaching this P. This Q is approaching P. So, and how fast does it approach the P? It is by what? By the quantity, yan, which is the delta y over delta x. And if you take the limit of that, delta y over delta x, as delta x approaches 0, then you will come up with what we call this tangent line, and the derivative of that is the slope of that is the derivative. Now, for the meantime, don't get disappointed if you won't understand. So this will be discussed thoroughly once we are already in the derivative. Now, the process that we apply to find the derivative is what we call differentiation. So it's like when you have two numbers, you add, so you get sum, no? So you get sum, and that is the quantity we derive, sum. What process do we apply to get that sum? Addition. So to get the derivative, we need a function because we apply derivative to a function. And once you have gotten the derivative, so the operation that you apply, differentiation. The operation. And the operator is this. It's like this is the plus equivalent. So d over dx, which is read as d over dx, or specifically derivative with respect to x, or d with subscript x, d with subscript, that is capital. But normally, d over dx is the operator we use. When you apply that to a function, you will get another function which is interpreted as slope of the curve at the point on the curve, no? Yan. So, and this is what the derivative, how derivative is defined. It is the limit of this quotient f of x plus delta x, the value of the function when your x is x plus delta x minus the original function, all over the change in x as delta x approaches 0. If this limit exists, then the value is what we call the derivative. In particular, if you know the value of x and you want to know the derivative at that point on the curve, or the slope of the curve at that point on the curve, so this is the notation. The f prime of a, or the derivative of y with respect to x at x equals a, is given by this f of x plus a minus f of a all over x minus a as x approaches a. Because as x approaches a, this is going to be 0. So, but not equal to 0, approaching only. And meaning, that change is what? Remember, delta x is x minus a. So, as x approaches a, delta x approaches 0. So, they are equivalent. But what we have here is specific value of x. Or, there is a specific point on the curve that is x equals a, f of a. A, f of a is the point. Okay? Yan. What about integral calculus? So for integral calculus, so this is what we have. Let's have an overview. The second branch is integral calculus. So this time, this deals with the study of the measure of the total net change of quantities. It concerns the evaluation and use of integrals to compute what? To compute, for instance, area bounded by curves, volumes of solids of, let's say, area generated, no? So you have a region, it generates a solid. For instance, how to find the volume of the generated uh, solid, no? And also, let's say you have a variable force. You push an object with a varying force, how to get the work done. So what's the value of the work done from this point to that point with a varying force? So that can be done using calculus. Without calculus, you cannot find the work done in pushing, let's say, an object from one point to another point on a horizontal plane. So from one point to a distance, no? So that's calculus. Okay? So what is the tool or what is the quantity that we are going to have? What are going to compute? Integral or antiderivative. Integral or antiderivative. Now to get this integral or antiderivative, we're given a function that is continuous. Again, a continuous function. But actually in advanced calculus, even it is not continuous, as long as piecewise continuous, you can still get the integral. But since this is just basic calculus, so we are going to limit to continuous function only for the meantime. But if you pursue, for instance, BS math or BS math, even piecewise continuity, you can get the integral. Unlike derivative, very sensitive. So, but for integral, there is a, what you call this, a consideration. So the process is integration or anti-differentiation. And the operator used this elongated S or may mga book A then with subscript X to mean antiderivative. So again, there are actually two quantities that we can compute. Indefinite integral and then definite integral. So there is a difference between the two. For indefinite integral, you will come up after computation a collection of functions, meaning there is no definite value, a collection of functions. While for definite integral, after computation, you will come up with a specific value. So that's the difference. You can compute. It's like in derivative. If there is no particular value, you will get a function after getting the derivative. But if you specify a specific value of x, you get the derivative. You will come up with a number also. A specific value or slope, no? Yeah. So how do we interpret this basically? So it is an area. Yan, that integral, definite integral, from a to b of f of x dx is interpreted as the area under the curve. So this is how it looks like. Yan. If you want to get the area of this region, like for instance, from this point to this point, so you can apply integral calculus. So let's say you want to get the area from this point up to this point. So that is a positive area because this definite integral is a signed area, interpreted as signed area. If you want positive, you get the absolute value. If you are really interested with the area. So what you will get is area of this, and that is positive. Area under here, considered negative because signed area. If you add, so this plus this, let's say this is 10 units, 10 square units, but positive. This one negative because although there's no negative area, but it means only that it is below. So you take the sum, 10 plus let's say 4, negative 4, it is positive 6 because the value of the definite integral. Because side area. If you want to get the total area, you get the absolute value in this portion of the definite integral so that it becomes positive 4. Okay? So that's the summary. And if you want good words, explanations, I gave you the link about calculus. The person is discussing or explaining differential and integral. Very nice discussion. Is that clear, guys? Okay, it's already time. So